The inspection process for electrical work generally involves multiple stages. Firstly, there is a rough-in inspection. This consists of verifying the proper installation of electrical wiring, devices, and other components before they are concealed behind walls, ceilings, or other finishes. Secondly, there is a final inspection. This is conducted after completion of the entire electrical system, including fixtures, appliances, and all other installed components, to ensure compliance with applicable codes and standards. For commercial jobs, the inspector will typically need to be present for both the rough-in inspection to verify the layout, wiring methods, and installation of devices and equipment, and the final inspection to ensure that the completed system meets all code requirements, operates safely, and fully complies with the approved plans and specifications. For a commercial job with 3/4 inch EMT and Wiremold, the following inspections may be required. For the rough-in inspection, verification of correct placement and installation of EMT conduit may occur, as well as review of wire sizing and pulling methods. For the final inspection, there may be testing of whole circuits for proper voltage, amperage, and ground continuity, examination of Wiremold raceways and receptacles, and confirmation that all installed equipment and fixtures meet code requirements. To proceed with inspections, 1. Contact the local building department to determine the specific inspection requirements and schedule for the area. 2. Schedule inspections by contacting the building department in advance to schedule both the rough-in and final inspections. 3. Inform the owner by letting them know when the inspections are scheduled and explain that presence will be needed. 4. Prepare for inspections by ensuring that all electrical work is installed according to code and the approved plans. 5. Attend inspections. Be present at both inspections to answer any questions and demonstrate the proper operation of the electrical system. By following these steps, electrical work can be properly inspected to meet all applicable codes and standards. It is important to understand the specific requirements of the local building department, as they can vary. Ensure that all wiring, conduit, and devices are installed according to the National Electrical Code, or NEC, and any local amendments. The rough-in inspection is a critical step to catch any errors before the walls are closed up. Inspectors will be looking at several key aspects of the installation. These include proper support and securing of the EMT conduit. Conduit should be supported within 3 feet of boxes and at intervals not exceeding 10 feet per NEC section 358.12. The correct use of fittings and connectors. All fittings and connectors must be listed for use with EMT and properly tightened. Grounding and bonding. The grounding system must be properly installed to ensure safety. This includes grounding the conduit and equipment. Grounding conductors run with the circuit conductors. Wire sizing and type. The correct size and type of wire must be used for the intended application and properly identified. Box fill calculations. The number of conductors in each box must not exceed the maximum allowed by the NEC. This is critical to prevent overheating and potential fire hazards. After the rough-in inspection is approved, the next step is to complete the wiring and install all devices, fixtures, and equipment. The final inspection is conducted to verify that the entire electrical system is safe and compliant with all applicable codes. The inspector will check various elements, including proper connections and terminations. All connections must be tight and properly insulated. Overcurrent protection. Circuit breakers and fuses must be of the correct size and type for the circuit they protect. Ground fault circuit interrupter or GFCI protection. GFCIs are required in specific locations such as bathrooms, kitchens, and outdoor areas to protect against electrical shock. Arc fault circuit interrupter or SI protection. SIs are required in many locations to protect against electrical fires. Proper labeling and identification. All circuits, panels, and equipment must be properly labeled for easy identification. Accessibility. Electrical panels and equipment must be readily accessible for maintenance and repairs. Operation of devices and equipment. The inspector will verify that all devices and equipment operate correctly and safely. In the case of Wiremold installations, the inspector will pay close attention to the following aspects. Proper installation of the raceway. The Wiremold raceway must be securely mounted and properly aligned. Correct use of fittings and accessories. All fittings and accessories must be listed for use with Wiremold and properly installed. Wire fill. The number of conductors in the Wiremold raceway must not exceed the maximum allowed by the manufacturer and the NEC. Grounding. The Wiremold raceway must be properly grounded. Receptacle installation. Receptacles must be securely mounted and properly connected. Remember that communication is key throughout the inspection process. If there are any questions or concerns, it is important to discuss them with the inspector. Inspectors are there to ensure safety and compliance, and they can provide valuable guidance. Understanding the inspection process and being prepared can help ensure a smooth and successful inspection. Familiarize yourself with the NEC and any local amendments. Maintain accurate records of all electrical work, including wiring diagrams, calculations, and equipment specifications. Have all necessary tools and equipment on hand during the inspection. Be prepared to answer any questions the inspector may have. By following these tips, you can minimize the risk of delays and ensure that your electrical work is properly inspected and approved. Remember to always prioritize safety and compliance with all applicable codes and standards. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. If you are not comfortable performing electrical work, it is best to hire a qualified and licensed electrician. An important aspect of preparing for electrical inspections involves understanding the specific code requirements related to conductor sizing and ampacity. The NEC provides tables that dictate the allowable ampacity of conductors based on their size, insulation type, and the ambient temperature. When selecting conductors for a commercial job, it is essential to ensure that they are adequately sized to handle the expected load. Overloading conductors can lead to overheating, insulation breakdown, and potentially fire hazards. NEC Table 310.15b16 and 310.16 provide ampacity ratings for conductors rated 0 through 2000 volts. These tables specify the allowable ampacities for various conductor sizes and insulation types under specific conditions. Factors such as ambient temperature and the number of current carrying conductors in a raceway or cable can affect the ampacity of conductors. The NEC requires that adjustments be made to the allowable ampacity based on these factors. For example, if the ambient temperature exceeds 30 degrees Celsius, a temperature correction factor must be applied. Similarly, if there are more than 3 current carrying conductors in a raceway or cable, ampacity adjustment factors must be applied to reduce the allowable ampacity. These adjustment factors are provided in NEC Table 310.15b3. It is crucial to perform these calculations accurately to ensure that conductors are not overloaded. Voltage drop is another important consideration in electrical installations. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors. The NEC provides guidance on calculating voltage drop and selecting conductors that will maintain voltage drop within acceptable limits. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices to trip and energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, reducing the risk of electric shock. The NEC specifies detailed requirements for grounding and bonding. These requirements cover topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. It is essential to follow these requirements carefully to ensure a safe and effective grounding and bonding system. Overcurrent protection is another vital aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. It is crucial to select the correct size and type of overcurrent protective device for each circuit. Using an undersized overcurrent protective device can result in nuisance tripping, while using an oversized device can allow conductors and equipment to be damaged. The NEC also requires that overcurrent protective devices be readily accessible and properly labeled. Proper labeling and identification of electrical components are essential for safety and maintenance. The NEC requires that all circuits, panels, and equipment be clearly labeled to indicate their purpose and function. This helps to prevent accidental contact with live parts and makes it easier to troubleshoot problems. Labels should be durable and easily readable. They should also be updated whenever changes are made to the electrical system. In addition to these general requirements, there may be specific requirements for certain types of equipment or installations. For example, there may be specific requirements for wiring in hazardous locations or for installing emergency lighting systems. It is essential to consult the NEC and any other applicable codes and standards to ensure that all electrical work is performed safely and in compliance with all requirements. When preparing for an electrical inspection, it is helpful to create a checklist of items to be inspected. This can help to ensure that all aspects of the electrical system are thoroughly reviewed. The checklist should include items such as conductor sizing, ampacity, voltage drop, grounding, bonding, overcurrent protection, labeling, and accessibility. It should also include any specific requirements for the type of installation being inspected. Having a checklist can help to ensure that nothing is overlooked and that the inspection process goes smoothly. It is also important to maintain good communication with the electrical inspector throughout the inspection process. If there are any questions or concerns, it is important to discuss them with the inspector. Inspectors are there to help ensure that electrical work is performed safely and in compliance with all applicable codes and standards. They can provide valuable guidance and assistance. Remember that electrical work can be dangerous. It is important to take all necessary precautions to protect yourself and others. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all safety procedures and guidelines. If you are not comfortable performing electrical work, it is best to hire a qualified and licensed electrician. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements. This can be done by attending training courses, reading industry publications, and consulting with electrical inspectors. Staying informed about changes in codes and standards can help to ensure that electrical work is always performed safely and in compliance with all applicable requirements. Also be sure to check for local building codes and variations to the National Electrical Code. By following these guidelines, you can ensure that your electrical installations meet all applicable codes and standards and are safe for all occupants. Remember that safety is always the top priority. The NEC provides detailed tables for conduit fill, which specify the maximum number of conductors allowed in a conduit based on the conduit size and conductor type. Exceeding the maximum conduit fill can make it difficult to pull conductors, damage the insulation, and reduce the ampacity of the conductors due to heat buildup. It's important to consult the appropriate NEC tables and perform calculations to ensure that the conduit is not overfilled. The tables you will need are in Chapter 9, specifically Tables 1, 4, 5 and 5a. In addition to the general requirements for electrical inspections, there may be specific requirements for commercial buildings. These requirements can vary depending on the type of building and its occupancy. For example, there may be specific requirements for emergency lighting, fire alarm systems, and smoke detectors. It is important to consult with the local building department to determine the specific requirements for commercial buildings in the area. Accessibility to electrical equipment is another critical aspect of commercial electrical installations. The NEC requires that electrical panels, disconnects, and other equipment be readily accessible for maintenance and repairs. This means that there should be adequate working space around the equipment and that it should not be obstructed by storage or other items. The working space requirements are specified in NEC Section 110.26. In commercial buildings, it is common to use various types of wiring methods, such as EMT conduit, flexible metal conduit, or armored cable. Each wiring method has its own specific installation requirements. For example, EMT conduit must be supported at specific intervals and secured with appropriate fittings. Flexible metal conduit must be properly grounded and bonded. Armored cable must be protective from physical damage. It is important to follow the NEC requirements for each wiring method to ensure a safe and reliable installation. Electrical installations in commercial buildings often involve complex control systems such as lighting control systems, HVAC control systems, and energy management systems. These systems require careful planning, design, and installation. It is important to ensure that these systems are properly integrated with the building's electrical system and that they operate safely and efficiently. Another key element for commercial buildings involves emergency systems. Emergency systems, such as emergency lighting and backup power systems, are designed to provide power and lighting during a power outage. These systems are critical for the safety of building occupants. The NEC specifies detailed requirements for emergency systems, including the type of equipment that must be used, the location of the equipment, and the testing and maintenance requirements. Ensuring a safe and efficient electrical system is paramount in commercial buildings, requiring diligent adherence to codes, meticulous planning, and skilled execution.